Okay, take a good look at this. It's a disposable vape. You've seen these things everywhere, right? But what if I told you that inside this little piece of e-waste, there's enough computing power to actually host a live website? I know, it sounds completely nuts.
Well, that's exactly what we're going to dive into today. This is all based on a really fascinating blog post by Bogdan Iohannescu, who took on this exact wild challenge. So let's see how in the world he managed to pull it off.
So where do you even begin? How do you look at something that's literally designed to be thrown away and think, yeah, web server? You know, it all started pretty simply. Bogdan was just collecting used vapes from his friends, mostly to pull out the rechargeable batteries for other electronics projects. It's a pretty standard thing for hobbyists. But then, inside one of them, he found something he absolutely was not expecting.
See, in most super simple devices like this, you expect to find what's called an ASIC. It's basically a chip that does one job and one job only. Think of it as a dumb switch. But when Bogdan cracked one of these open, he didn't find the usual black blob of resin covering a simple chip.
No, he found a proper programmable computer chip, a tiny little brain where there should have been just a button. And that single discovery is what kicked this whole incredible project into gear.
So, okay, he found a real computer chip. But what are we actually talking about here? I mean, just how powerful could a chip from a disposable vape possibly be? Well, have a look at the specs. We are working with some very limited resources here. The chip runs at a blazing 24 megahertz. It has 24 kilobytes of storage and a teeny tiny 3 kilobytes of RAM. And yeah, you heard that right, kilobytes with a K.
To put that into perspective for you, your smartphone is probably more than 100 times faster, and it has something like 2 million times more RAM. This isn't just old school tech. By today's standards, this is basically a fossil. Now, most people would look at these specs and just laugh it off, right? Not much to work with. But Bogdan, he saw a challenge. He saw the potential for what he jokingly called a blazingly fast web server.
Okay, so we've got a chip. But here's the biggest hurdle. This chip has no Wi-Fi, no Ethernet port, absolutely nothing designed for networking. So the huge question becomes, how on earth do you get this thing connected to the internet?
And the solution is just this wonderfully clever three-part hack. It basically combines modern-day debugging tools with some seriously old-school networking tricks from the past. So first, he used a feature called semi-hosting, which let him turn the chip's programming port into a kind of secret data tunnel. Then, to actually send internet data through that tunnel, he pulled out an ancient protocol called SLIP. Just think of it as a piece of software that makes the chip act like an old dial-up modem. And finally, to understand the language of the web, he installed a tiny bit of code called UIP, which is like a lightweight translator for all that web traffic.
And it worked! Well, sort of. Because that blazingly fast web server he was dreaming of, yeah, the first attempt was, anything but.
The initial ping time was around 1.5 seconds. That's 1,500 milliseconds. For context, a decent internet connection is under 20. And loading a simple web page? It took over 20 seconds. It was so bad, it was actually kind of amazing.
So what was the deal? The problem wasn't the hardware, it was the software. His first version of the code was sending and receiving data one single character at a time. It was creating this massive, slow-moving traffic jam.
But the solution was so elegant and simple, a ring buffer. Think of it like this. Instead of trying to carry water one drop at a time, he built a small bucket in the code to collect a bunch of drops and carry them all at once in bigger, more efficient batches. No hardware changes at all, just a smarter way to move the data.
And the results were just staggering. That ping time plummeted from 1,500 milliseconds all the way down to just 20. And page load times, they went from a painful 20 seconds to a super snappy 160 milliseconds. He had actually done it. He had his blazingly fast web server.
So with the speed issues totally solved, the final question is, what could this little server in a vape actually do? How capable was it?
Well, the final project was also incredibly efficient. Even after loading it up with an entire blog post, it was still only using about 20% of its storage and less than half of its RAM. That left plenty of power to do other things.
And we're not just talking about a simple static web page here. To really show what it could do, Bogdan added a dynamic API. You could actually send a request to the vape, and it would tell you how many requests it had served and even report back its own unique chip ID. It was a real interactive web server.
In the end, this whole thing is so much more than just a really cool hack. It's one of those projects that just makes you think. It shows the incredible, hidden potential inside the millions of electronic devices we treat as disposable. And it leaves us with a pretty big question. What else are we throwing away that we just haven't looked at closely enough?